Hello? Yes. Am I audible? Yeah, you're audible. Good afternoon. Now we will start at 7. Yes. So we will start at 7. So have you successfully registered for the course and for the exam? Okay. What do you do? Not assignment answer because till the deadline is not passed. So we will first discuss basic, like what are the issue come in this course, as well as then we will deep dive into similar question, not the exact question, because still the deadline is there, right? Yeah. So, so that's the. Don't worry, the answers will be out, and but I cannot provide. Mm. But you can ask the, yeah, you can ask similar doubts like why you are not able to understand or something like that. Not the exact answer, but yeah, around things you can ask like why. Okay, let's start. Others will join. Time. So, first of all, in the hierarchy of the courses, like which is because since it is a aerospace department course, so I will talk in terms of aerospace, like where this course lie and what is connected to this course. So as the name is there, element of mechanical vibration. So this is not a standalone course. It it has the requirement of many different areas, and so it is um, undergraduate course which is graduate, and the graduate course which is undergraduate, something like that. So in between that. Now, if we have studied the like talking about the from the aerospace department term, first we have before that if we have studied theory of beams, because the last chapter is about the continuous system. So there the knowledge of theory of beam, for example, Euler-Bernoulli beam and the Rayleigh beam, Timoshenko beam, that is required. But for the last week, okay, and you can go from there to composites, which is a huge topic in aerospace department. So it is actually an architectured material. So we are making a material with a specific properties. Then we go in this direction. So more toward the applying stuff. And in theory of beam, if we have 1D kinematic reduction, so this becomes structure. So this becomes structure plus cross-sectional analysis. So it's like if you have a beam and you have a detailed study about it, and if you assume it to be an 1D element, then we come to this theory, what do you call it? Theory of beam. Okay. Um, this will come here, and here is if you so theory of beam. What we have learned is in the form of static, like what will be the stress if static force is applied or something like that. Okay, so if you add dynamics to it, it will become the last week of this course. Okay, and before that, this comes theory of elasticity, again a huge field in mechanical as well as aerospace. It is also called mechanics of material. And from there, this composites come. Okay, and in that, if you make kinematic conception of 1D, so also if what your aim is, so what is type of analysis you are doing, so cross-section analysis, then it becomes theory of beam, where we assume things such as Euler Bernoulli assumption that cross-section remains, so they are not dependent on each other. So that is so that becomes the theory of beams, and now coming more upon top of it, then we have solid mechanics. The solid mechanics can be of many types like 3D and initial value problem and boundary value problem. And in that, if we assume it is linear plus elastic plus static, so that becomes our theory of elasticity. So whatever we are going to be learning in this course are all linear. Okay, so the distinctions have been made from the solid mechanics only. And if you need some specific behavior, for example, there is a piezoelectric material or some material which in which the property changes with time. Then we come to inelastic material. By the way, composites can also be termed in that. So it is not elastic, it is plastic now. Again, the assumption is static. It won't be linear problem now, it will be non-linear problem. Okay, there is one more thing on top of it, and that is kind of father of all studies, which is continuum mechanics. Now, from this, if we go to solid mechanics, we come to structure side of aerospace, and if we go to fluid mechanics, then we have aerodynamics. Okay. Now, this general classification can also be for this classification can also be for mechanical, but what makes a difference in aerospace and mechanical? Do anybody know here? One is composite. Like in mechanical, we don't study that much composite as it's in aerospace because everything is composite here. Do you get the question? Like in these, why we are studying and uh, how it's related to aerospace? Okay, so continuing the mechanical engineering topics. So, okay, okay, Devashish, you can unmute yourself and answer. It's okay. Okay. So my question was yes. So my question was, what is different here in mechanical as well as aerospace? Like, in some topics we study more, some topics we study less in these fields. So what are those topics? For example, composites are studied more in aerospace as in mechanical. Aerodynamics is one, yes. So this is our aeros. Hmm. Yes, vibration. So there will be distributives here also. Okay, I will come to that. But right now we are talking about what are the topics which are more um happening in aerospace. Hmm. So yes, we cover actually. We cover, and I will be giving you distributives after this. Okay, how it's important mechanical vibration. I will just give you the idea. Uh, So yes, till now you are correct. That aerodynamics as well as composites are the two fields where uh, uh, aerospace is more prevalent. But the father of everything is continuum mechanics. Okay. Now let me name some more general purpose topic because these are connected to all of these in some manner. I will make a separate box and put general purpose formulation and solution approaches. So in that first comes finite element method, our favorite topic. Okay. Then comes energy method. And finally tensor analysis. See, my point is not to make you uh, show a lot of topics. My only aim is here to connect things. Okay, if we have learned tensor analysis, we know that tensor analysis is mostly for if we have more dimension mode. So if something is in 3D, then tensor analysis is very much helpful. Energy methods are used when we are using not Newton methods, but Lagrangian method as well as the Hamilton approach, Hamilton law of varying action. So their energy methods are used. Finite element method is very much used because finally we have to solve the system, and the system do not necessarily have the exact solution. So we have to make a numerical solution out of it, and that is the where finite element comes to the picture. So I will just write these are all important topics in aerospace engineering, and it is in general very useful if you have knowledge about all these. Okay, because finally everything will be connected at the end of it. Okay, right now it's not end, it is just continuation. Like whatever course we are doing, it's just part of the whole story. Okay, so we have reached up to structural dynamics. Now we will make a whatever is in aerospace, we will make a separate color. Okay, now I will uh, give you more aerospace topics. Okay, now in theory of beams, if we have different types of cross section, in that if something is particularly thin walled, again open and close, anything can work. So this becomes our aircraft structure. Again a huge topic in aerospace. Okay, now we had this aerodynamics here. Let, let me bring it down. So aerodynamics along with one more topic. So blue R for aerospace, aerodynamics along with one more topic called as flight mechanics. Okay, these two topics combined, it affects the aircraft structure. Alright, so there can be maneuver of the loads, okay, and there can be another maneuver of load, and that area is called aeroelasticity. and structural dynamics is connected to that. Okay, or our mechanical vibration is connected to that because it is a form of vibration. And if we go for lumping and weighted residual method, we can end in vibration of discrete system, which we'll be learning in from the second week of this course. If we have two particles connected by string, how the response look like, so something like that. To complete everything, let me write this topic, which is most prevalent in robotics. Okay, so everything is connected here. So this is a huge. Now this is all about formulation. We still haven't seen what the analysis mean in this in these topics. Anyone having any doubt regarding the whole chart? This is just a rough chart made by me, um, just to connect things like where you are and what background do you bring in and where you will be going after that, because you all have joined this course for some reason, right? Can we know some of the reasons why you have joined this course? Okay. Okay. So any variation is happening, you wanted to know why? Yes, Ramjan. Okay. Okay. Okay, great. So for gate perspective, I will just say to cram up the formulas. Okay, I will be telling you which formulas to cram up, and then it will be done. You don't have to know each and everything. Just go looking at the what the question is, and then what the solution will be. All right. Again, I couldn't hear. Yes. Yeah. So finite element method. So you are saying CAD level, right? CAD 2. What is CAD 2? Vibration certificate. Okay, so it is mostly experimental, theoretical. CAT to. Oh, okay, industrial. So yes, see, once we will dive into this subject, we will learn about 1 degree of freedom, then 2 degree of freedom, and then we will come to multi-degree of freedom. Okay, and from there we will have a small introduction of continuous system. So theoretical knowledge you can only gain from linear perspective. Like you can convert everything to this finite element method. Okay, and everything is now in term of I will say matrices. Okay, so if in a industrial level, if you are looking how this course will affect, it is because in that we use pre-existing software such as ANSYS or some other software abacus, and that helps in simulating the environment. All right. So, but what is yes? So experimental. That's what I'm saying. That experimental. How you can know about that? So there is uh, this has a counterpart. This whole subject has a counterpart where it's called modal analysis, which is also part of this course. Now, element of mechanical vibration, what does it do? If you have a system, you will get the responses. Okay. But modal analysis do the opposite thing. If you have the responses, how can you find the vibration characteristics? Okay, so what pros do is it read out the responses at different points, and how now you can find the vibration characteristics. That is the whole game. So yes, you will get to know about that also, because how much is damping, and what are the experimental way of finding the damping. So that you will get to know firsthand. Okay. Any more who have joined this course and this? Mm, okay. Okay. Right. So you want to brush up things so that you can solve a problem, right, in your company. Great, great. Yes. Yeah. So see, this course was recorded some years back, and what is new is you already have the knowledge everywhere. Okay, but how to apply those knowledge, and for application perspective, because we all are engineers, right? So how to apply that knowledge to your particular field to get the desired result, that is an important part of this learning, and that NPTEL I think exceeds other things. I just know that in a few, like in last semester I had two Russian students, and so international students are also taking part in this, and they also are very comfortable with this NPTEL, because everything is taught in English, and so they also understand, and with very basic level. So yes, but the thing is, if you have some problem in your mind, then from the starting itself, you should massage this course to solve that problem. Now we have some experimental studies in this course, so you can use that. Okay, if you have a particular example which is near to your problem, just start solving that problem, and everything which is required will come in the way. Okay, so you will get to know that where you have to put more effort. Alright. So for gate perspective, I will say just cram up the formulas. I will be telling you which formulas to cram up. But for problem solving, you should find the problem which is already solved. Okay, a near problem, and then you can start away from there. Okay. Yes. Okay. So how I am doing this course is like I have part of, like I have been TA of many courses. This is somewhat a basic course for me, but I have been part of a TA of nonlinear vibration also, and advanced dynamics, and dynamics of like from robotics perspective. So I have a, I will say, umbrella view of things, and right now I also started a comic series. So how I do dynamics is, see, dynamics is something which changes in time. Okay? Anything which evolves in time is called dynamics. Now there, everything evolves with time. So the thing is, what I do, how I teach is, I correlate with interesting stuff. Okay. Now this is the part of curriculum. But what if I say that everything here is a part of DC universe or Marvel universe? How will you react to that? Like if I say that I will be framing questions in which a Batman is swimming in that way, and Superman is flying that way, and how the drag will be. So will that be more interesting? The question is, So there are ways of teaching. One is to solve the regular questions and just forget about it because you will be cramming up the formulas. Okay. Another way of teaching is you relate the question in some familiar manner, which kind of generates the curiosity in you. Okay. For example, um, this example I have done in nonlinear vibration because nonlinear vibration has lot of solutions. Um, so you all know about DC Universe, comics, DC Universe, Batman, Superman. You've heard, right? So Batman. And have you heard about Joker? Okay. So now my main area was this guy, and I wanted to teach nonlinear dynamics, or in our sense, it is nonlinear vibration. So whatever we will be covering in this course are linear vibrations, okay? And so it has input and output is one. Like if you have one input, you will be having only one output, okay? But what and in nonlinear dynamics is this is linear. There is one input and there could be lot of outputs, okay? Like you cannot uh, kind of beforehand know that what the response will be looking like. For example, just now there was one guy who said that he wanted to apply this in his company, like some problem he had to solve. So that we will be solving in the linear sense. If you go in the non-linear sense, you cannot judge a machine how it will react. Okay, so it is like knowing the future beforehand. If you know what the vibration characteristic will look like, and if you can convert that system into a vibration system, linear vibration system, you can know how the responses will look like. But in non-linear system, what happens that you don't know what the solution will look like. Have you heard of term chaos? Have you heard about this term chaos in general sense, not in the yes? So it actually means that it is yes, confusion, right? So it has a lot of meaning, but confusion is being one. So what Joker do is it spreads chaos, okay, and it's like it is of this regime where if Batman do something, gives some input to Joker, the Joker will give infinitely many solutions. Now Batman cannot guess that much what he will be doing next. If it had been some other villain, let's say some lower level villain as uh, some villain one, okay, like a thug, any thug who is stealing money from any woman in that Gotham City. Now it has only one output that it will run away. Okay, so we know that it is a linear. Batman can easily solve that, but Batman cannot solve Joker because he is non-linear dynamics. Okay, so something like that I have made lot of correlations. Okay, so this is how I teach stuff. But don't worry, we will be in the linear domain and we will be solving examples where these characters will come and they will be you will be at that position, you will be that hero and you will be solve hero heroine, you will be solving that problem in that sense. Okay, will that be interesting or should I go to normal question solution? Great, because I know that the number keep on decreasing as we progress. So in my course, it will be like the number will keep on increasing because people will be gaining interest, okay, in this type of questions because they are there. The YouTube video will be open to all, so anybody can watch it and it will be very interesting to watch. You can see my old videos also. It is similar like that. Regarding the notes, I will be providing this link where this everything will be there. Okay. Now, this is from my point, like what I will give. Now, from you, you all bring as many questions as you can. Okay, because it is 2 hours journey, and if you wanted to hear a story, then it's very good. But if you wanted to solve a particular problem, then because I don't know what problem you will be facing, okay, so I'm here to help you out in that. So you can also, I'll be giving my WhatsApp number. You can post your problem here also. When I will get time, I will look at it, or in the class also, I can solve that problem. Okay. So, anybody have any general question regarding why we are doing this course? I think we have way above that because you have already to join this course. Yeah. Okay. Do you have any question? You all have any question? Okay. So I won't go into the detail of why we are learning this course and what kind of why this course will be useful because you all have your different reasons to do this course, but some of these reasons are uh, people wanted to find out critical loading, okay, and maximum stress scenario. So we have done that for theory of elasticity, where static beam is there and we have applied the load, and now we are finding where the maximum stress will be. But that is done in static sense. Now we will be learning how to do it in dynamic sense because dynamic loading is much worse than the static load. Okay, because it creates the instability in time. Static, we know that if it exceeds some value, it will break. For example, buckling. If you provide buckling any load which is more than the buckling load, it will break. For example, this. Now it can withstand up to some amount of force, but after that it buckles. Okay. So if we start away provide some big force, it will buckle. But if something is waving in time, then it depends on a lot of other things. For example, in aircraft, in aerospace, we have a term called flutter. Have you heard about flutter? Aircraft flutter? Yes. So aerospace people know about this because this is a huge thing in aerovelocity where the structure is affected by the aerodynamics and the aerodynamics again is affected by the structure. So it's a coupled problem. It is something like we have um, two springs which are attached to each other. Okay, if you start by beating the first uh, spring, the other will also get affected. Okay, but what if the effect of this, the second one, is on the first one again, and it is unstable kind of thing, where like if there is one person and I slapped him, okay, he slapped me back harder. Now I also slapped him much harder, okay, and then he's also slapping me more harder. So it's like our whole faces are gone, right? So it's like unstable system. So this is called stability studies, where we find out if there is coupling thing. So is it making the system unstable or towards the stability? Okay, so everything is here is connected to controls, robotics, where you are getting to stabilize the system and get the system known. Like it shouldn't give different responses which you don't need. Okay, so this is called dynamic instability. Okay, now one more topic is fatigue. You have all heard about fatigue. Like we also feel fatigue because, for example, right now it's like 7 p.m. to 9 p.m. It's like evening time and you're still studying and I'm teaching you. So it's like this is a one form of fatigue because whole day you have been busy with something and now you are again doing classes, which is mostly chill time and you are still studying. So that's like fatigue. So for the long duration, if something is dynamic, it has a tendency to fatigue. So what, how it is tackled is by in this there is a we have made a assumption called linear assumption, elastic. So this elasticity loses. Elasticity has a time limit. If that happens, the system becomes inelastic. Okay? So that is where fatigue comes to the picture. Another is over time the performance also reduces because of this inelasticity. Now, if you take a rubber and you start doing like this for much longer period of time, it will eventually break. Okay, because it is not perfectly elastic. Now, for example, the person who said that I have a torsion system, so they needed performance certification of that machine. So hence, the vibration analysis is must. Then, if there is any wear and tear assessment, also the energy harvesting. Energy harvesting is the term where if something is moving and you are extracting energy from that and you are recharging your batteries. Okay? So these are all topics which are uh, kind of connected to mechanical vibration. Anything which is having the repetitive motion is considered as vibration. So lot of examples are there. Swimming, for example, okay, heart pumping, and birds flying. So everything is a which is dynamic and periodic. I will say it is a vibration. Now this course is actually a very introductory course, and so I will give you a brief. This are also taught this thing, the same thing in end of the lecture, where mm, there are four major steps in this analysis. So we call this a vibration analysis. First is called abstraction. Another is called formulation. The next is solution, and finally validation. Anyone having an idea what abstraction is? Problem statement. Oh, nice, very good. Like I think this is by far the best definition I have got when I have asked this question. Problem statement. Wow, great. Okay. So let me put that. Uh, so there is one thing called engineering, and there is physics, and there is mathematics. So what engineering stand for is mostly the decision making, and what physics is mostly understanding or insights. And finally, what mathematics is for mathematical modeling and solution. Everything is necessary, but there should be a balance between these. If balance is not there, it will either take a lot of time and like there is a optimization. Okay, like for example, a company wanted to complete a project. Now, in completing that project, what is much more required is this thing. This is required to some level. This is required to some level, but basically, it is required that decision had to be made. If a task is given, for example, there is a uh, let's say there is a shaker machine, and someone wanted to find it how much uh, vibration it can handle. Okay, and you started uh, putting probes at every centimeter, and you started uh, measuring all the vibrations which it can. So, and you are doing only that, and then you have a huge amount of data, let's say some petabyte of data, but you don't know what to do next. Okay, that means you have the uh, you have the nick of this accidental thing, but you don't know what the theory is. So you don't know physics. You don't know how to apply these maths. Okay, then it is a problem. Now, one who is well versed in the physics, like how the vibration actually happen in physical world, as well as mathematics, like how you can model it, like you can, like instead of using hundred of probes, you can use only three or four probes at very smart location. But smart location come from engineering and as well as physics. Like you are converting that system and explaining what the problem statement is. Okay, so that is called abstraction, where you are what you are actually doing is you are reducing the reality, because if you are solving the reality and then it is a continuous system, it has an infinite degree of freedom. You cannot model each and every degree of freedom, but you can model smartly into some degree of freedom which are important. So that is called abstraction. I will give you example of abstraction just after this, and every class we start with abstraction only. Like we will take a real life problem. It can have some superhero also, DC or Marvel, uh, and we will reduce that reality to a mathematical model. Okay, what does it require? So reduce reality to an entity, and that can be modeled mathematically. So, for example, if you are designing a skeleton inspired by a kangaroo, okay, so you are making kangaroo legs, which is used for hopping. Now you are studying the kangaroo first because you wanted to learn how kangaroo can jump from one place to another. All right. So how you can do that is you don't model ears of kangaroo. You model its legs, right? So that is what abstraction is, where you are modeling finer the legs, and you are whatever is not required in that analysis, you remove that. So you are reducing the reality to entities that can be modeled mathematically. Okay? Then comes the formulation, where we determine the governing equation and boundary condition as well as initial condition. Okay. Then next is, once these governing equation as well as boundary and initial conditions are found out, by the way, it is all dependent on abstraction because abstraction only will get to you those equations, and then the formulation is mostly the mathematical part, and also the finding the solution is also again a mathematical part with little engineering to it because you are using some numerical method to solve that. And finally, it's like checking of the accuracy. That is validation by comparing with it because you need something to compare with, comparing with the experimental or reality. Now, for example, that kangaroo example. If you are designing some kangaroo leg and then the response of your model is near to the actual kangaroo jump, then your model is good. Okay, and if that is not there, that means either you have under model the thing or over model the thing. Okay, so those are different errors, and in short, everything is dependent on this decision making, but with essence of physics and mathematics. If you don't have physics and mathematics, it won't make sense. And it can be that without engineering you can solve the problem, but it will be not optimized solution because it will either take a lot of time, lot of effort, okay? And the solution which you got, there is no need of that. For example, how the kangaroo's ear will react if jumping is happening. Okay, so something like that. So our emphasis is mostly in this course is mostly in these three things: abstraction, formulation, and solution. Now, modal analysis is one in which we go for this validation, which is part of this course, but not the entire part of the course. So it's just a beginner course, so that's why. Uh, Now, this validation uh, in this course have been done in specific assignment, and also there is a experimental part of this course, so you can watch that also. So our main goal is to understand the physics of the vibration using this reduced order. We call this as a reduced order mathematical model. Now, if there is a building and you can convert that building into 1 degree of freedom also, okay? But it will give you the response for the particular degree of freedom which we have designed it. And if we talk about aerospace related structural dynamics, then we work like this only. Like we convert the whole system into degree of small degree of freedom problem, and then we try to find the essence of what is happening in that particular problem. Any doubt till now? Okay, so you are not having any doubts, so I should ask the question then. Don't worry, I won't pinpoint. Uh, it's just an open class. Uh, it's for your knowledge only, and if you want to do this course or do this class, it's all your choice. So now, let's say I am a engineer, okay, and I'm using linear analysis to find um, stress of a beam. Okay, so my question is, will I overestimate the model or underestimate the model? So my question is, if you have a beam and you are using the linear analysis to solve that problem, will you overestimate the stress or will you underestimate the stress? So this is question which is asked in a lot of interviews. Okay, so I think many of you would have heard this problem. You can give the solution. You can do. Okay, great question. So it is like if you have some cantilever beam, okay, and you have applied some load, let's say P, and we know that stress is generated, and you wanted to find the maximum stress. Okay, now it's understood. So that maximum stress, will it overestimate from the actual stress or underestimate from the actual stress? We are still in static. So one have overestimate. Which analysis? Linear. Oh, okay. So you are saying it will be equal, huh? Okay. Yes, yes. Mm, mm. Overestimate. So no. I'm saying like, see, the question is, if you are finding the stress from the mathematical model which is linear, okay, will that stress value will be more or less than the actual stress value in that component? For example, let's say maximum stress happen at this point. Okay. Now the maths found out that the stress is 150 megapascal. Now what the actual stress will be? It will be 140 megapascal or 150 megapascal or 160 megapascal. So we have one equal. So one here and one overestimate. Overestimate means this one. Any underestimate? Underestimate, okay. Any any more? Um, Reply? It's all raw now. With one more option, overestimate. Mm-hmm. Okay, great. Mm. Hey, the thought train is good, I will say, for now. Uh, can you, let's see, okay, let's solve this problem now. See, um, in linear problem, what happens that if we draw the stress strain curve, any stress strain, it can be true stress strain or normal stress strain. So, in linear sense, it will be like this, okay? And do you know what actual stress strain look like, right? So, at the same value of strain, if something is at this point is 150 megapascal, okay, so the actual stress was 140 megapascal. Understood? So in this case, linear model has overestimated. Okay? So overestimate is correct. Yeah, that underestimate you are going correct because the system is not linear. Okay, you are correct in that sense. So this guy here, all right? Yes, yes. True stress strain, like it will also have the similar characteristics, right? Like it will bend after some point, right? The true stress strain curve. Hmm. Yes, that's what is the difference between how we are modeling things and how the actual things are. Okay, uh, we are lucky that we are doing this course and everything will be here only. Okay, so we are we have made a big assumption in the starting only, linear. That essentially means that we are in this area only. We are not getting past that. Okay, so if there is a spring mass system and this thing, if we have cited, and it's an undamped system, okay, there is no damping, it will come back to its original place. Okay, but we know that in reality it doesn't happen like this. Okay, so that's what it's not uh, like nothing in this world is linear. It's only a, what to say, it is the way of looking at things. The non-linear, yes. This is not a correct statement because it might be that for particular this case it is okay because we are overestimated thing because we know how the actual characteristics look like. Okay, but if you are assuming things, you might be underestimating thing also. For example, that building. If you assume that that building is only 1 degree of freedom, you are essentially underestimated thing. because there can be winds which will be affecting the system. There could be many things. All right. So it's not correct statement to say that whenever we are assuming things, it will essentially go to overestimation. It can also go to underestimation. Okay, it can become a joker. Okay, it can become something which you cannot handle because you don't know how it will react. The best what we can do is we can change the degree of freedom and then watch if what the response is like. If it is towards the real thing, as you're increasing the number of freedom, okay, or dimensionality, then you are moving more toward the then you are moving more toward the real sense. Okay, but you cannot find the perfect solution. So you are just approximating to the point where it's needed. For example, you know pi value is 3.14. Do you know what is after that? Yeah, something something. But do anyone who remember everything? No, no. You only need something which is required up to that point, such as least count or so. This is how engineering works. You don't go and learn what happened. That is the point which I made here. Like if someone is from mathematics background, okay, pure mathematics background. Now he will be interested in knowing what is after 3.14 and how that number is changing and is there any pattern to it. That is like pure mathematics person. Physics person will get to know that how this 3.14 come to in the picture. So we know that if the circle and diameter, if we divide it, we get 3.14. That is a part of physics. And what is a part of engineering? Is we only know 3.1428 and we apply it and to find the area of the circle or the perimeter of the circle. This is what engineering. Now same pi has three different meaning to three different persons. Okay, so similarly, all these things have different meanings, different agendas. What is required is first the problem statement. So Ramachandran, I really am very impressed because I haven't heard anyone answer this perfect. The abstraction is problem statement. So problem statement, first you have to define the problem statement, why you are doing this, and then you will be defining what the accuracy is, what is the precision is. All right. Any more doubt regarding this? Yeah, then it will be changed. So let me go a little further in this course. So you have this, you have seen this equation, right? Mx double dot plus kx equal to 0. So this is linear equation. All right. Let's say there is a linear problem where there is q x, let's say alpha x cube. Now this is a nonlinear problem, and this is a linear problem. Do we have solution of both? Yes, we have solution of both. Actually, we can find the solution of this. But now I will give you one more problem. This is signum function, okay? I'm making it tough as I can remember. Mod x into some discontinuous function, more discontinuous function, mod of signum x. Now, now does it has a solution? exact solution it doesn't have. Okay, so this is where engineering is required. See, up till now you had applied mathematics, like this is a differential equation, ordinary differential equation, and you are solving using the method which we know, like in our. So these methods we have learned in mathematics, but their mathematics still we are learning things. Okay, and exact solution we don't have all the exact solution. We know the exact solution of this, so we can find the solution of this to some point, but we cannot find the solution to this. We can only find the solution of this part. This part is very tough to find. Okay, now I will give you one more correlation. Let's say you're a veterinary doctor. Okay, and you specialize in cats. Understood? You are a veterinary doctor and you specialize in cats. Cats meaning the household cats. Now you came to a jungle now and you see a tiger. Now will you react in the same way as you do the household cats? Like these are cat, you go and stroke her back and everything. But will you go and stroke the back of the tiger? No, no. So that is the point which I am making. That this is kind of linear, and this is called not cat. Now there are a lot of things which is not cat. Now let's say if there is a dog, okay, whatever you do to the cat, you can do to the dog because all are household. But you cannot do that to the panther or cheetah or even elephant. It depends which elephant. Like if it's a household elephant, it's okay. But if it's a jungly elephant, it will romp you and go away. Alright, so something is like what real life is also. Whatever we think is linear, but actually it is something is affecting it, so it's a non-linear problem. And then how? So that's what happened in real life also when you are in company or anything. For example, stock market. If somebody know that how the stock market is behaving, then there won't be economy as such. Like you won't spend money in mutual funds and the trading because it is unpredictable. That's why you spend there and you invest in such, okay, which has ups and downs again. I'm not the what do you call it? I'm not giving you ad of mutual fund, but giving you a example. That if something is uh, not known prior a prior, so for example, a cricket match, interesting cricket match where both opponents are equally uh, equal. So now it's a you cannot know the ending in advance. Okay, so hence you make a team in dream team and those things. So it is like you are applying the linear analysis to a non-linear analysis. Okay, and up to some point you are getting the results. So what is at some point is this limit. Okay, let's say there is a match between India and um, which is the lowest team. Let's say Papua New Guinea. Okay, then you know that India will win, right? So that is a linear problem. You know what the outcome will be. But let's say if Pakistan, not Pakistan, it's already gone. So now if there is Australia and England, you are again there is a equal chances. No, it's unpredictable. Okay, you don't know who will perform good, who will perform better. So that is like non-linear analysis, and it's a huge field by itself only. It's like you have specialized about cat, and now you are learning about panther also. You are learning about tiger also, elephant also. How many animals are there, right? You cannot learn about everything. You can have an idea of which are the dangerous animal, where I have to run, and animals which I can pat the back. Okay, so that's what we learn here. And my way of teaching is you become Batman and you decide yourself that how to solve the problem. Okay. Okay. Moving on. Uh, any doubt till now? Okay. Okay. So I will make some changes in this notes and then give it to you. Okay. Uh, so I had already have some. So you wanted to solve question from today class, or should we discuss it like what, how this course is, an overview of course? What do you want to do? Overview of the course or start solving the questions? Overview. Okay. So more overview, right? Okay. So okay. So now since we are more, more toward engineering, right? Everyone here is more toward engineering. Yes. So okay. So anyone which is from mathematics background? Oh, great, 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 great. So now, in physics, you'd uh, now see we also have a mix of crowd here. So because why this course is there is to connect all these things. How much practically we need things and how much is things in reality. Okay, reality is very strange, by the way. So now in physics term, we talk about space and time, and we know about waves. We know about the wave is the equation which is space as well as in time, and now anything which is periodic in time is called vibration, any matter, and so it can move in the space as much it can, but at a particular time period it should come back to it at the same point. So that is called periodicity. So it can be the reason can be very different. Okay, so I'm writing some of them. So these vibrations can be motion induced. Okay, let's have a discussion on this. Mm, okay, uh, F equal to ma and F minus ma is equal to 0. Do we have difference between these two? Any difference between these two statements? Yes, no, no. Okay, it's all about perspective, right? This is called Newton's second law, and this is called D'Alembert principle. So, which one you have learned? Like Newton law, right? You have learned. So, do you know what are the disadvantages of using Newton law? Let's say rocket. A rocket is there. Why you cannot use Newton law here? Yes, this mass is changing. Mass is changing. This is one of the thing where Newton law cannot be used. More, more example. Let's say yes, relativistic. So let me uh, give you more idea because you are from physics background and others have to get to that point. So let's say in this system there is one antenna and I am one ant sitting at the antenna. Okay. Now, what force will I experience? Mass of ant. Okay, gravity. And let's neglect gravity. We are in space, and let's say it has a ant suit or something. Uh, what I'm saying is mass of ant into acceleration of ant is equal to F. Only this much force I will be having. Yes, I'm getting that. So, see, this is going with some acceleration, acceleration of rocket. Will that acceleration of rocket have some effect to this ant? Yes or no? Have you heard about centrifugal force, pseudo forces? Pseudo forces, you know, right? So it will experience a pseudo force. So actually, the, these two statements are different. This is saying that it is a Newton's law that if there is no realistic moment, like we are in the non-inertial, sorry, inertial frame, okay, then we don't have to worry about uh, the if there is a coordinate change and those things, we don't have to worry about those forces. But this F minus MA is pseudo force. Okay, so to a nutshell, if I am saying what will happen that if there is something moving with respect to something and you wanted to know that something that what the forces will look like, so it has addition of the forces which is because of the first movement. Okay. So this is called transport theorem that is very much necessary if you are which is if you are in aerospace. So hence the position, velocity and acceleration of the frame in which it is moving, it is also important of system as well as its reference system. We will solve a problem where a disk is there and ant is there, okay, moving on this disk, and this disk is rotating with omega. Now this had to go, let's say there is a female ant and this ant wanted to meet this female ant, okay, and it started moving in this direction, but something happened that it went some other way because of this movement of this disk. So that problem we will be solving, that pseudo force will come. So hence more scientific if someone asks like what are the formulation method, so there are different formulation method. One is by Newton law where you draw the FBD of the system and then you try to judge which direction it is, and then you find the force balance and moment balance. That is one way of going. Another way is energy methods where we start with how much energy the system has, the kinetic energy, the internal energy, as well as so in internal energy the strain energy comes and the external forces energy. Okay, and those energy we put into the formulation called Lagrangian equation of motion or Hamilton law of bearing action. From there, we directly get the equation of motion. Okay, one way of getting equation of motion is using Newton law of bearing action, Newton's law, But if you have some frames moving with respect to each other, then it is tricky, as well as if there is some non-constant item. Now, non-constant item are not covered in this course because it's a non-linear problem. But if it is a linear problem, then uh, movement of the coordinate, it actually it affects the system. It's still linear, and but you cannot directly apply the Newton law. Okay, so beware of going through the Newton law. If the frames are all in rest, then only you can apply. Okay, so moving on, yes. So first is uh, position, velocity, and acceleration of the system as well as reference system. Then inertia forces, which is primarily due to the mass, and in this course it is constant. If time permit, I will solve a problem where mass is also changing, and it still has a exact solution. Okay. Then dissipation due to damping mechanism. Now this upcoming week's not week 3 is all about damping. So this is the cause of the vibration, like the equation of motion. So this mx double dot plus kx plus cx dot is equal to 0 or ft. So this is what equation which will be working on. This is inertia forces. This is mostly the stiffness forces where the system is elastic. Okay, elasticity is there, and this is dissipation, and this is external forces. Okay, these are the primary uh, source of vibration parameters. Then moving on to formulation. Here we have applied loads, then equilibrium equation, which is covered in the Newton law, then compatibility equation, then stream displacement relationship, and then constitutive relationship. By the way, all these are linear for us. Then boundary conditions, and initial conditions. So these much data you should know before formulating any problem. Okay, and upon that, now you should know which method you have to go. Okay, output can be the internal stress, strain, as well as deformation. Now it can be anything: displacement, rotation, shear, twist, etc. In everything, we have space and time as independent variable, and so uh, to get the overview of thing, we have whatever we have learned up till now: statics of structural static structural analysis. It is a part of something which is called structural dynamics, or this, and this is a part of mechanics course. One thing which I have missed here is how to formulate things, like uh, how to know beforehand that how many degree of freedoms are required. Okay, for that we will dive from the next class about degree of freedom, like what actually degree of freedom conveys. And also we then will be able to answer one more question about discretization. So do you all know what finite element method is? Okay. Okay, do you wanted to know? Okay, see, let's say, mm, let me just check if I have some abstraction. Yeah, we have to solve an abstraction problem, right? So let me just check if we have some abstraction problem. We will solve one problem here only, and we will cover different aspects of problem. It will be a fun problem where a real life situation I will give, and what we have to do is we have to abstract things. Like we have to put engineering to a reality situation, which is what we are all trained for. You can take 5 minute break. Till then, I will just search that problem. Then it will be a fun activity. Let's take a few minute break. I will also restructure myself. Don't worry, I will be just setting up the problem for you. Okay. Ready? Interested in whatever you are seeing? Okay. So let me start with the problem statement. Abstraction. Okay. So abstraction needs a problem statement. Uh, I wanted to learn that why cheetah is the fastest animal on land. So I have this problem statement where I am interested in devising making a device which by which I can also travel as a speed of a cheetah. Okay, because I too have two hand, two leg. I don't have a tail, but I can manage with something which can be a tail. Okay, so but I wanted to learn about how why cheetah is the fastest animal. Any ideas how to move forward? Great. So we will go in depth. Okay, we know that what the problem statement is. Now we move on that how the cheetah moves. Now, if you will look carefully, the head is steady, like it is at the same position altogether, as well as the end of the tail. Okay, so these can be a static part. Whatever is moving are the two legs, two hind legs, and now I just wanted to know your comment that why cheetah is the fastest animal on earth. What is extra in cheetah? What is what do you say special in cheetah? See, tiger also have the same structure. Cat also have the same structure. But why cat is not the fastest animal? Cheetah has some power, some special power. Now can you? Yeah, from the body structure, what you can know? Yeah, but, see, it's the great. You are going into the right direction. See, whenever you are going to the right direction, I will say warm. Okay, warm. Huh? Weight. Uh, Yeah, weight matters, but not that much in this case. Yeah, it matters, but there is something else which is special in this cheetah, which kind of make it stand out of the all other animals. Weight is there, but again, lower weight animals cannot travel at such speed. So whenever we are going near to the solution, I will say warm, and whenever we are going away from the solution, I will say cold. Okay. Have more discussion. See, I will say it's a one word solution, and like if I will give you that solution, it won't be that much interesting. Cheetah, we know we have learned from when childhood it's the fastest animal, right? But why? That is the main. I will again uh, show you the animation. Okay, let's discuss. Cheetah. Leg. Cheetah legs are there, but again, legs are not that much uh, important. Like other cats also have, like big cats have legs, such as panther has legs, such as this. Running style. Warm. Coming to the warm. Said that it has a different proportion of sizes, right? That is also warm. What? Yes. Backside is what? No, backside leg is okay. No, that is not. Again, see, as such, the frog has the longest leg, that thing, but it cannot run at that speed. Legs are not arrangement of what? Yeah, what is different? Not leg is not different. Something else is different. Joints of legs are also same. Like length of the legs are also same. Something else have elongated length. I have given you a hint. Yeah, why are you? I'll be showing you a skeleton if muscles are there. Cold. Warm is something is long here. Cheetah has dash longer than other animals. Again, tail is also not okay. Yes. The spine, actually, the backbone of the cheetah is very elongated. So that is the thing why it is the fastest animal. I will prove it to you in abstraction. Okay, but before that, everybody is satisfied with the answer. Backbone is little elongated. Can you see it's protruding? It's like now. Let me show you the figure again. See, it's compressing and then releasing the energy. Compressing, releasing the energy. Backbone. Look at the backbone. That you will see um, animals don't do that. Okay, and that gives the extra energy to this cheetah. Okay, now that is like general knowledge. Now we will what we will do. We will do the engineering here. Okay, so first of all, the information was about how the cheetah is moving. So we have converted this cheetah into these many degree of freedoms. Okay, and now we wanted to learn that if instead of cheetah's backbone, if one spring is there, how will the solution look like? Okay, so this is what abstraction is, where uh, we have divided the cheetah's backbone into segments. Actually, if you've seen the skeleton, it is segmented. So it can be considered as a beam. Okay, a beam which bends and store energy. That is important. A beam which bends and store energy. Now, from our abstraction point of view, we can make a more refined problem statement that how much energy is stored in cheetah's back. Understood? Now, if some Nat Geo guy is there and who is married to an engineer, okay, and now that engineer is asking that Nat Geo person that I wanted to have an analysis of cheetah, why it's fastest animal on earth. Now you keep yourself into that position and then do the analysis. Since he or she is your partner, so you cannot say no. Okay. Otherwise you won't be happy. So to do that, you have put all your engineering here and you have divided uh, this kind of structure and analysis, done the analysis, and you find out how much this energy this spring can store. Okay, and once you have done that, you will take more springs there, and you have to just see that because of the springs, the energy stored is getting more or less. If it's getting more, then you are going towards the correct model, and if it's not getting more, then something is wrong. For example, here, so this is the front side of this cheetah now. Okay, front side. So this is a backbone only. So this backbone is it consists of uh, um, discrete torsion springs. Okay, now this is what formulation looks like. This is uh, less number of degree of freedom problem, and this is more degree of freedom problem. Okay, Any comments? Yes, going toward the more accurate result. See, our aim was to find how much backbone energy it can store. Okay, but you cannot go infinitely many springs. So it's like you will come to a limit. After that, the solution doesn't change that much. For example, again 3.14. If the solution comes 3.14, good enough. If it comes to 28, good enough. After that, it's insignificant. Okay, so let's say you get this solution till n equal to 24. If you take 24 springs, you get the solution. So you don't have to go for n equal to 30, 50, 100. Yes, yes. Okay, so do you know your heart is also a mechanical object? And do you know about pacemakers? It's an artificial rhythm provider. How can a pacemaker know how much rhythm to provide? So it's all science, okay? It's all engineering. This is all what world has come to, and still evolving to things, to more complex things. Okay, so see, everything comes with a thought. Here, the thought was that why this cheetah is the fastest animal? Why? It was why. Okay, to answer why, we came to a concept or hypothesis that maybe the energy stored in the cheetah's back is more, because then only it can provide the energy that much. See, everybody has his own capability, but if something is aiding in that capability, for example, um, you are anyone know swimming? Okay, so let's say if someone gave you uh, some kind of gloves which covers this in between fingers area, will you be able to swim faster? Yes, right. So it's like if something is aiding to your movement, it is making you better, right? Better than others. So similar thought is, if cheetah has something additional, like additional energy is coming from somewhere else, so what is that reason? So from why we came to how much, how much energy, okay, and from that we started modeling the problem. Okay, see, this is not what I have done. This is how things are taken care of. Okay, everything comes with a thought. Like, what if this is there? What if that is there? Okay. Mm. So I am a PhD student in Department of Aerospace Engineering in IIT Bombay, and my area is more toward perspective. Like, I work in very simple field called periodic systems. Okay, non-linear periodic systems, and in that I specialize in aero servo velocity. So it's like aero velocity is a topic in that if you add controls, we get aero servo velocity. And non-linear periodic system is like you beforehand cannot know the solution because it's a non-linear problem. Not all non-linear problems have exact solution, so we go toward the numerical methods. In numerical methods, it is similar kind of assumptions where we describe the system and say that this is important, that I have to throw away. Okay, and this is because, see, in this diagram, can you see cheetah's ears or cheetah's mouth? Right? You cannot see because that is not important. What is important is cheetah's back, and hence only cheetah's back was there. Why leg was modeled? Because we need excitation from where the force will come. Okay, hence legs are also modeled, and whole backbone is a stiff beam, because we are saying that only one flexible part is there, which is spring, and whatever the spring will contain, it's a cheetah's back. Now what we are doing is, instead of that rigid beam, now we're taking a flexible beam. You can take a beam instead of this torsion springs. Okay, you will get similar results. Now again, when you are converting the continuous system into a discrete system, it's your choice or engineer's choice that how many degree of freedom you need to consider. Okay, so my field, I was telling about my field. So my field is, if something is periodic, like a person, let's say a comet. This is Earth, this is our Earth, and let's say there is a comet, and its path is something like this. Let's say this is Alpha Centauri, our nearest galaxy, and it travels like this, and every 10,000 year it come near Earth, okay, which we can watch, such as Halley's comet, okay, which is periodic, but it is non-linear because it is affected by lot of different planets, lot of different sun, lot of different gravitational forces, even Jupiter, okay, but at uh, fixed some thousand years, it come to this position again. So this is where periodic system are considered, nonlinear periodic system. So what my research is about is, I can, if I know that how many time period it takes, I can convert this initial value problem, like where it started from initially, like when, 1 second, let me reconnect my iPad. So my my research area is where I convert this initial value problem to a boundary value problem, because I know where the system is after one time period. It is the same position. Okay, so I use this in computational domain and try to find the solution. This is what my area is. It started with a thought. Okay, so that's what I wanted to convey you using my own example, that everything comes with a thought. Do you have any other queries till I connect again? Yes. Mm. Yes. Okay, coming to that. See, what shaft problem is, shaft is for torsion. Okay, bending is for, like bending. For example, this is there, so this is bending, as cheetah's backbone. Shaft is for this movement. Okay, we don't need this movement for now in our abstraction. We need this movement, or we can also recreate this movement by using torsion springs here. Then again, it becomes a bending kind of thing. Understood? Yeah, something which a bending happening, because the cheetah, it stores the energy in form of bending. Okay. Next class, what we will do? We will do a cat example. Do you know, if you If you just throw a cat from 11th building also, 11th floor also, the cat will land on its own feet. Do you know about this? Don't do it. Don't try it. This okay? Don't try your cat and throw it. I'm just saying it happens for about 3 4 floor. It happens. The cat actually land at its own feet, and it's recorded that it also do it from 11th and 12th floor also. And do you know the cat woman is based on that character? Cat woman is based on this phenomena, and it has a physics to it. It has a physics to it. From next class, similar to this our backbone problem, we will solve a cat problem. Okay, from next in next Tuesday, next week. We are near end of the time, and it's still taking a time to. I think I have to change my app, Google Meet app. So let's see. Yeah. So how do you like this class, by the way? Okay. Yeah. Yeah, that had to be because we have 12 weeks to go, 2 hours each. So I had to make this interesting. But can you gain? Yes. Mm. Just go. Ready? Yes. Where do that come from? Ah, yes, you are going to right direction. Why the gyroscopic action is there in cat? We also have 2 hand, 2 feet. Yes. You can speak in Hindi also. Don't worry. Hmm. Okay, that is one reason. That is one reason. Yes, but there is one more reason which by which with the senses, why the senses is kick in because of some physical thing happening. A physics is happening there. Why some physics is happening? So we will let's put trailer for the next class. Okay, otherwise everything we discuss here only. Hmm. Okay, so are you gaining something from this class? That is what my query was. Are you gaining something from this class? Like, see, we will start with the questions and we will solve those things. That is a different thing. It will be part of this weekly classes. But are you gaining something extra? Okay, that's what I need because that's what actually is what is missing. Sorry, I cannot hear you. Hey, still thamba, still a lot of things had to be learned. Okay, it's like I'm just saying that if you it comes from now the wisdom comes in the picture. Why you go to an expert is expert know each and every detail. Like it has a wisdom. Why to take this step? Why not to take that step? Okay, it comes with time. Okay, you can only know the way, but there are so many variables to it that it needs an expert. I am not expert. I am still doing my PhD. Once I have done, I can be called as doctor. Then I will be expert on I will say vibrations. Still, there are a lot of fields to cover. It's again something like cat. Okay, I only know cat, and there are a lot of different animals to learn. Okay, so still early to say that you know that how to do the abstraction. In upcoming class, you will get a feel of it. What abstraction is, how. reality can be converted into a mathematical model, but I'm saying that there are lot of different companies which do this and they fail miserably. Okay, so okay, we are back to action.
So
Yes, yes. Okay. Uh, so I will just sum up things, and then we can wait for if you all can see my screen. But where is notification? Okay. So next class we will start with cats abstraction, and then we will solve the problem which are near to our uh, quiz questions. Okay, the assignment questions. So we will have interactively we will learn about what the problem wanted to tell us. Okay, and we will correlate with some sci-fi world or some other thing so that it is easy to learn. All right, the concepts. Okay. Okay, so I officially make this class over. Thank you guys for coming to this class. Bye. Good night. Bye. If you have any doubt, we can chat. Otherwise, you can leave. Yes. No, no, it's a weekly class. Weekly class. Yes. Oh, okay, okay. Nice. Very good. So this kind of class is there for only practice. Okay. Hmm. You have made RC plane. Wow, great. Hmm. Wow, great. Nice. Okay, but coding is must. Yeah, now it's not that must because ChatGPT is there, so you will get over it. Don't worry. Yes. Hmm. See, we have now AI to do the coding. Now the much consideration is not on um, coding because now AI is there. It will do all the coding work. What is required is engineering, that wisdom. Okay, that is the thing which will make you apart, just like cheetah. Oh, okay, okay, okay. So there is one YouTube channel, Torque 4712. Okay, you can follow that guy. He has a lot of videos on how to join ISRO or some aerospace. Uh, yes. Did it flew? Did it flew your RC plane? Okay. Okay, great. Okay, good. See, one way you can go conventional method. You can make the what do you call the control algorithm of everything, and another way is you can experiment. You can experiment. Might be you find something new. Okay, and that is like what our pioneers have done. APJ Abdul Kalam and everything. Everyone has done similar work. Okay, they have pioneered. They have followed up to some point, and after that they had made their own. point. Okay, so you can do that. It's upon your interest, purely on your interest. Okay. Mm. Nice. Hey, that's huge. Crashing is not an issue. You have flew up to 2 minutes. That's very very huge. Wow. I think then you can have one more friend in your group who is interested in controls. Okay. Okay. But there will be someone they ask me. Wow. In which college are you? Oh, okay. Okay. I think your college would be some rocket team would be there. Yeah, you can join that actually. And see, academic pressure will always be there, but you keep on doing these things because this will finally matter everything. And you keep on writing what you have done because let's say if you apply for something else, you can write all these things. Just open your journal and start recalling what you have done and how it went. Okay, just a small journal kind of thing. It will also rejoice your what achievement have you done, and then how you can move forward. Like if there was no way, and then you have made a RC plane in under 2K and flew for 2 minutes. That's a huge accomplishment, I would say. Okay, so you're lucky. Mm. Oh. So there are a lot of competitions. You should invest yourself a little more to that. But don't worry or don't keep your studies going on. Okay, I will just say that keep time for that, but keep your studies also going on. Yeah, so you are lucky in that sense. Oh, great. Don't want. Yeah, so Java, but you have to do it. Basics you have to cover, okay? Because let's say you are using ChatGPT, but you don't know basics also, then it's a huge down. That much is needed. Yeah. Okay, so actually I have to go have a dinner. Okay, so let's call off a day. Then let's talk next week. All right. Okay. Bye bye. Bye. Yes. Okay. Yes. Oh, sorry. Yeah, we will cover. So I have spoken a lot of Hindi also, but did you understand all those things? Language is not a barrier, right? Language. Okay. So see, the topics which I have told you are somewhat. If you know them, it's good. You can connect those things. If you don't know them, don't worry, because we will be covering in the further course, because we have 11 weeks to go. Okay, so all those things are just for connection. Like if someone have done, see, this is NPTEL course is from a lot of different backgrounds. Students are there, so everyone has different reasons to do this course. For someone who wanted to begin, it doesn't mean that you should know each and everything. I will be guiding you on that. Okay, for example, damping and those terms which I have through this time is just to connect things. Okay. Don't worry about that. Any more, Paula? See, the assignment which you are doing are sufficient. The thing is, yes. So I'm saying the assignment which will be which are asked in this weekly assignment, no, that is sufficient. Hmm. If you are able to solve that, you will be doing good in the final exam also. Good.